啊，温习吧。
不行了，不的难还是简单？
简单吧，
跟期中比，简单很多。不复习。
啊，啊， 你都做了没？
哎，你第二个，OK，
啊，
对不起，
做到哪了？
对不起，
就我饭咯，
没看到
没看到？啊
那个，不是
啊
每一个
啊！这周呢？
这种让你看，感想，
什么感想啊？结束了哦，想不到我也撑了一个 semester。反正那个桌子一直不见的，那个桌子不见。
不懂。
So last lecture will be a revision lecture. So first hour we will finish the work, see the question. So we'll spend about half an hour doing it, and then we'll try to do the KMM question. And then we will discuss at least one KMM question. Okay. 2.4. Okay. And then second hour we'll run through the content. Which part is important? Discuss about the quiz. Any question on it? I try to do at least one question. 12.4. And I will discuss the question. Run through the question. Thanks. Ừ. Ờ, try one question from 2024 at least one from 2024. 没有在干嘛？可以说。
相近的两个只能有一个要么对，要么往地方。哎，这不知道能去哪去。代码这个是那个是我的事情。
And let's run through the question so that when you go back, you know what to do. Okay, 12.1.353637 are similar flavor. So in 12.1.35, you are asked to prove either golden mouse. Okay, just using the definition of golden mouse. Okay, so I saw some of you use the truth table to prove it. That one is like proving equality. So you can use this algebra way to prove it. Okay, so you can use zero to create a new element. Okay, and then you can use distributivity to distribute the element, and I can see that one term disappear. It's get signified to one. Okay. That you can create another element just using 0 and 1 or 1. Yeah. So you can see that the 5 laws can induce new law. And just using the 5 law, you can create new laws from them.
X is also clear.
Yeah, you can prove anyway, down to up to the but the key here is to play around with the 0 and 1. Play around with 0 and 1. So this means that the identity is very important. 0, 1. I don't comment. Okay, so that's okay. About 12.3, the reason I put this question, this question might be looks simple. The idea to put this question is I want you to imagine every time you see this expression, right, there's a gap behind your mind. Okay, whenever you see this expression, there's a logic gap behind your mind. And the key of this topic is to minimize the circuit, minimize the expression. So your target is to minimize the circuit. I think this one we also do it in the proposition function as well. Definitely tell you that in the exam, I don't ask you to draw this. I need to draw this thing in the exam. Just want you to keep your mind that when you see this expression here, there's a gap behind your mind. Okay. Then our job is to minimize the gap. Okay. So next is the key of the topic. 4.2. This is to ask you how to build the K-map from the expression, from the function expression. So if you have 3 minterms, make sure you have 3 1 in your K-map. If you have 2 minterms, you have 2 1 in 4 1 in your K-map. Okay. Make sure you label your K-map properly. Okay. You have to make sure that every cell that are adjacent to each other, they only differ by 1 literal. Example, in this case, in this 2 times 4, right? You cannot put you cannot put you cannot put y bar z bar beside y z. Okay, because they are differ by 2 literal. You have to put the neighbor cell or the adjacent cell to be differ with exactly 1 literal. Example, yz and yz bar, they only differ in z. It doesn't matter how you arrange them. For example, you can start with yz bar as well. Z bar, y bar, z bar, y bar z, yz, and then yz and yz bar. So how you arrange that, you have to make sure the cell, the adjacent cell are just differ exactly 1 literal. Okay, exactly. And make sure you know how to draw the. Don't simply arrange this. Make sure they are one literal different adjacent function. Make sense? Make sense? Okay. So let's see how to simplify this. Okay. Okay. So in the K-map, right, you want to draw using the largest block, okay, to cover the one. So block of product of power of 2. Okay. So you get 1 times 2, 1 times 1, 2 times 1, 2 times 2, 4 times 1, 1 times. Only block of products of power of 2. Okay. Why? Because, for example, these two implicant here. Okay. So we can combine these two into S bar. Why? Because S bar Y plus X bar Y bar is equal to X bar times Y plus Y bar. Okay, by the distributivity law. Right? Okay. And then Y plus Y bar is 1 by the complement rule. Then you get X bar. Okay. So we can combine X bar Y and X bar Y bar. Okay. Then okay, so in two variable one, are you guys okay with simplifying? Okay, two variable. Two variable. Okay, three variable one is a bit annoying because you can see that there's a lot of possible overlapping of blocks. Okay. So in K-map, right? In K-map, you need to draw all the possible prime implicant. Okay. So what does it mean by prime implicant? Prime implicant means the block of one is not contained in a larger block of one. Okay. So you can see that in 12.4.8 here, what I draw here, okay, there are how many terms here? 1, 2, 3, 4. Hey, why I only have 3 terms here? Oh, okay. Yeah, this one is a combined term. Okay, so for example, there are 4 midterms here, right? Okay, you need to draw all possible prime implicant. You know what I mean? Okay, so you cannot draw something like this. Okay, the purple one is not a prime implicant because you can draw a larger block that contain it. Okay? So every time you see the K-map, you need to draw um, prime implicant first. Okay? And then you need to determine the least number of prime implicant that cover all the one. Make sense? You need to find the least number of prime implicant that cover all the one. This is what you do in Kevin. And yeah. What are essential prime? So essential prime meanings the block of one, which is the largest block that cover the one in the K-map. So for example, these are all essential. Okay. because the one they cover, they contain one that's only covered by that block, not by the other block. Showing the other. Okay, this one here. Let's look at this D here. Are there any essential prime independent? All right, because if you look at every block, all the ones are covered by the other block. You can see here. If you pick one block here, then this one is covered by this block, this one is covered by the other block. Okay, so you can check for all the blocks, they are not essential. Okay, so but they are prime. They are prime, right? Because they are not containing your block. Okay. From five of these, right? How you pick the least number of block that cover all the block? How you pick the least number of block to cover all the block? Hmm? How do you pick? You can talk about the implicant. So, for example, this block corresponds to y, uh, x bar y. Yeah, this is x bar y. This one is x bar z bar. This one is uh, sy bar. And this one is z. Okay, let's see or not? See. So you look at this block, right? So this block is x bar yz plus yz bar. So it's simplified into x bar y. Right. And similarly, you can do the simplification of this block here. So yeah, so which block you will pick? Let's try any idea which block you want to pick. Any idea which block you want to pick? You can say the implicant. Just start with one and see how it goes. You got 3, 1, 2. What do you mean by 3, 1? Selections. You mean how to select? How to select? You need to find the least number of blocks that cover all the one. So there are 5 choices here. Right, 5 plus 1, 2, 3, 4, 5, 6 choices here. Okay. So how many blocks? What is the minimum number of blocks that you need to cover all the ones? How do you go? Z. By Z, I mean draw. By Z is this one. And then that Z makes sense. SZ. This one. SZ. Right? This two. X, Y bar. xy bar, xy bar, this one.
X bar Z bar.
X bar, Z bar, X bar, Z bar, this one. Okay. But in principle, you need to check whether this is really the list number or not. So you need to try whether you can cover it by 2 blocks. You need to check. Yeah. Because in principle, you don't know whether you cover it right. Okay. Sometimes you find it 4, you see, you think that there is the list number. Okay. So you need to try. Try. So you need to try. Example, for example, someone asked me yesterday if I don't draw all the prime implicant can or not. Okay. So for example, if you just draw 4 of these, right? Okay. For 4 of these, you cannot pick 3 the cover all the one. You see? If you don't draw all the prime implicant, okay, let's say you just only draw 4 of these, right? Okay, in the green one. So if you have 4 of this purple one, right, you cannot find 3 implicants to cover from this one. You see? So make sure you identify all the possible prime implicants. Otherwise, you cannot find the minimum. You might not find the minimum numbers. Can see can understand? Can understand? So you need to draw all the possible prime implicants. Okay? Otherwise, you might miss the answer.
这里答案，
啊？
它的答案。
Okay. 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 And so your job is to find the least number of prime implicants. Yeah, similar to the QM method, the Queen-Minkowski method. Okay. So for example, in the 12.4.22, right? Okay. So first, what you do in this method, actually you should see some similarity with this method and the K method. Yeah. So what you do is you list down all your term in your function first. Okay. And then you change your XYZ into big string. Yeah. If it is X, you put a 1. If it is X bar, you put a 0. Yeah. And then so on. And then you also combine adjacent cell first. Yeah. So if they are differ with 1 literal, you combine them. Yeah. For example, you see 1 and 2 differ by 1 literal. So you can combine them. And see, differ in Z. Yeah. 1 and 3 differ in 1 literal, differ in Y. Okay, so you can combine them. So you check all the possibility. Okay. And then you also check for 2 with all the possibility. Okay. 3 with all the possibility, and so on. Okay, you combine them. So once you simplify it, you put a dash. Okay. For example, XYZ bar, Z and Z bar combine to 1. So it become a 1 dash. There's no Z anymore this time. Okay. And then 1 and 3, y is a where y got simplified, so there's a dash in y. Okay. Got it? And then you keep going on. So the next step also, if you can find two minterm that is differ by one literal, you can combine them. For example, this one and this one. Okay, they only differ in one, right? So you can combine them again. Make sense? Okay, so you just keep doing it, repeat the algorithm, check all of them, and then combine until you cannot combine anymore. So you stop. Okay, so why you can combine them? What does this mean? They are one literal meaning different. So that means they are actually not the prime implicant, right? Because there's a larger block that contains them. So you can combine, you can simplify them. Okay. So those terms that you can do, that you can simplify again, they are contained in a larger block. Okay. So what is left is the prime implicant. So only the leftover one is what you want. Those are not used to combine is a prime implicant. That's what you want. Because it's not contained in a larger block. If it contains in a larger block, then it can get simplified again. Make sense? Okay. And then the next step is this table here. So this table here, right, actually correspond to this number here. Okay. Is which term you use to build them. This cross here is the term they are used to simplify to get the prime implicants here. And then you need to find the least number that cover the function. You see a similarity between KML. You want to find the least number of prime implicants that cover your function. Okay. So this method will work for more variable case, because more variable you want to draw the diagram, you want to look at the block, maybe it's harder to explain. So this one is systematically every step simplify until you get all the prime implicants. And then the next step is to tabulate the prime and then see what is the smallest step of prime implicant that you need to cover the function.
我看到最后是怎么样
？How to pick?
？How to number?
Okay, how to give final answer to this table? So you need a set of implicants that cover the function. Okay. So if you look at x here, okay, if you look at x here, x will cover the first 4 minterms. Okay. So you need to cover the 3 more. Okay. So if you pick, so you need to pick minterm that cover these 3. You need to pick the prime implicants that cover these 3 minterms. Okay. So Z cover these 2 and Y bar cover the rest. Okay. So you need to pick 3 of them. X plus Z plus Y bar. Okay. So maybe let's see other examples. Okay, maybe this one then. Okay, this one. Okay. So this function I got 9 minterm to cover. Okay. And then I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Also 9 prime implicant. Okay. So Your job is to pick the least number of midterm to cover. Which one you want to pick to cover? Maybe you can try this one. Which prime equation you want? This one? Want the first one? Okay, because first one only cover 7, you still need to cover the rest of the 8 one. So you say you want to pick the second one. Okay, pick the second one. Okay, so you cover 1, 2, and 7 now. Okay, which one you want to pick? You need to cover 3, 4, 5, 6, 8, 9. WY bar Z bar. WY bar Z bar. Where's it? WY bar Z bar here. Okay. So you cover 1, 2, you covered 7, you covered 3 and 6, and then this one. You cover these two. Okay, you still need to cover 8 and 9. The last one then. Okay. Then you need to check whether this is the least number or not. Okay. What's the least number? Okay. Yeah, the least number is 5. Okay, this also good. Okay. If in some case you found out 6, then you need to reduce again. Okay. So you need to check whether this 5 is the least number or not. So you need to try whether you can find 4 or 3 or 2 cover them. If it is not possible, then 5 is the least. Okay. So you still need to check whether this is the least number. Okay. Okay. Any question on K-map or not? How to reduce the K-map? How to find nation of circuit using K-map? Okay. Okay. Okay, maybe we come back at 10:17 and then we'll do the summary. Yeah.
这个表格就是检查的呗，这个表格
Uh-huh.
就是检查它到底有没有把全部的那个
啊，对，
就检查的呗。考试的时候我们用画吗？
考试，
还是说我们只要最终的表达式和这个过程？感觉考试的话应该不会出很多那种项目，出10多项那种，应该不可能，应该就6、7那种。但5、6、7这种应该就很明显了。
没有啊，考试其实是 K-map
这个
什么？
就没有这个。你好，
但是等到对象 这个值的这个
泡沫
啊，
也是全泡沫，
什么叫全？
就是从 topic 一 topic 那个全部
没有，就
在这块就是说
期中过后，
期中过后的，期中是考到哪里？那个方婷
开始
啊
啊，
方婷是哪个？
这个
那个
啊，那个什么 A 级及 C 级的。
啊，
有比较难。
这个基本上单词的这个
这一个大片啊，然后这边再把片拿完了，保回那个。
它是一两个核弹，就是没有。要不然你就看它是二倍。
那可以变，是要2倍长。
还是机票
定了，
啊？你订机票吗？
嗯，
你订啥？
17
你是在这边批完证再走吗？
差不多，没有啦，
哪能批完啊？得实习呀。
17
我们是4号，
嗯，
没有告诉什么时候必须。
好，
啥时候
3天后到5天啊，比较
？3
多
天后和5天后，我们有一个老师
啊，
是我们就是 Principle of Computer Competition，这老师期中卷还没批完，现在
我们
不知道人家就开摆，这老师期中卷还没批完。感谢你，要是让他3天内批完，感觉到后面我们还考了个 quiz，但是人家也没批完。这个老师他是属于那种就是带我们 tutorial 课
啊
那个我们这是个大课，教2个系，他就负责我们系。
啊
太有意思了。
咋证明题没有，
就是
没有，
没有证明题，这是
是那种也简单啊，就像 quiz 那种，就是证明
就是
那些 definition 的吧，
前面那些有，
也都是前面，没有那种，
就是没有不用写什么 law 之类的，
耶，
这个也不用。
这个没
哎，老师，
呀
你说证明的是，因为假如说
呀
就咱那个 midterm 不出了一道证明，他得把中间的就那些定理啊，
对
得写上，
然后
不写扣几分。
所以
假如说，假如你有
说
辅导，不写扣几分
1-2分吧，
，OK，那就不要。
没有啦，没有，不需要， 没有啦，没有那些证明，没有证明。
现在只是在公司。
就考
哎
是
是吧？
我们最后考的模块是6、9、10、11、12，
确实。哎，啊，
是的。
Everyone can see or not? No need to close the light. Need to turn off the light. Okay. Okay. I passed down the attendance list just to sign the last time for the record. Okay. So the final exam will be start from counting. Okay. Everything after the midterm. So what do you learn in the counting? So you learn product rule, sum rule, okay, the inclusion, exclusion. Pigeonhole, okay, pigeonhole. I wanted to put in the exam, but too rush, so no pigeonhole. Okay. And the permutation, combination, okay. So one thing you have to know is this binomial theorem, okay. How to use the binomial theorem. You need to know how to use, okay. So quiz question, quiz 3, quiz 4, quiz 5 is very important. Okay, they are very similar exam type question. Okay, quiz 3, quiz 4, quiz 5. And then in my exam, right, I think you should know me well already. You should put down the rule you use. Okay, those rule with name one you need to say state. As for example, this product, sum, and so on. If there's no name, those corollary, there's no name, that's fine. For example, the planar graph one, you don't need to remember the name. Just need to know how to use them. Okay. For those that has name, you need to know. Okay. binomial theorem. So those with name on you need to know. Okay. Next is relation. Again, relation, we talk about equivalence relation. So what's the definition of relation? Reflexive relation, symmetric relation, transitive relation. Okay. You need to know their definition, need to be able to prove something is symmetric or not, or what. Like the quiz question. Okay. There won't be very hard proof question, just some definition checking. Yeah. Okay. So remember that relation is a subset. Is a subset of a Cartesian product. It's not a connection between two elements. It's a subset. Yeah. You need to remember the definition of relation is a subset of Cartesian product. And then inside equivalent relation, we have equivalent counts as well. And then next is the partial ordering. So where we change the symmetry to anti-symmetry, then we got the partial ordering. From this partial ordering, we can order the order. And there's order inside this element. It's totally ordered or it is well ordered. Okay. Yeah. Okay. And then from there, we can find the maximum element, minimum element, and then upper bound of a set, lower bound of a set, greatest lower bound, lowest upper bound, and all these interval. And then lattice, lattice you also need to know. Okay. How to determine whether something is a lattice or not. I don't think it's very hard the question, but the example you should all the examples you get to it. So if you can finish all the tutorial right, I think can guarantee about 80 marks. 80. Yeah. If you finish all the tutorial. Okay, there's one thing you need to take note here. I always talk about divisibility, right? Actually, it's not Z, it's Z plus. We only define on positive integer. Okay, we don't talk about -3 divide 3. Okay, we always talk about positive integer. So if you see in the exam, right? Okay, it's a typo. So you just regard it as Z plus. Okay. When you see Z, this thing here, you see something like this. Okay, you just regard it as Z plus divide. You don't need to ask me in the exam. You just change it to Z plus as a typo. It's similar with this quiz also. I think some of you will recognize it and then change it. Okay. Just change it to Z plus. Okay. Okay. Any question? Okay. Just feel free to interrupt. Okay, next one is graph and trees. Okay, graph and trees. So graph and tree is quite a long topic here. Okay. So first we talk about the locality of the properties. So we talk about vertex and then the degree of vertex, okay, and then the neighborhood, right? And then adjacency matrix, incident matrix, okay, and then also the handshaking theorem that relates number of edge with the degree of vertex, okay. And then the next part is bipartite. Okay, so how to check bipartite? You need to check the chromatic color is 2. Right? So some of you spend time in the quiz, try to partition the vertex, and then spend too much time. So what you can do is you just color the graph, whether you can color with 2 color or not. You can, then it's bipartite. You cannot, then it's not. Next is Euler path, Euler circuit, Hamilton path, Hamilton circuit. Okay. only Euler path and Euler circuit have definite answer. Okay. That's mean for Euler path, Euler circuit, you only go and try and keep drawing whether you can draw or not. Okay. Just go and count the degree of the vertex. Okay. If you want Euler path, that's exactly 2 odd degree vertex. Okay. And then these 2 odd degree vertex is exactly the vertex you need to build the Euler path. Yeah. So in the exam question, your quiz question, right? I don't need to check your Euler path one. I just need to make sure your starting and the ending is correct. If you start with even vertex, then sure, very wrong. Okay. Your Euler path cannot start with even vertex. Must start with these 2 odd degree. And then Euler circuit, you need to make sure all the vertex is even. That's all. Hamilton path, Hamilton circuit, not much condition. Maybe Hamilton circuit got the Halls and Dirac's theorem. Also on the degree of the vertex. So this is a planar graph. Okay. In planar graph, we have the Euler formula. And then the 3 corollaries, if G is planar, then some inequality is true. Okay, but a lot of you use the wrong direction. You say that when the inequality is true, then it is planar. Okay, this direction is wrong. There's no backward direction here. There's always forward only. Okay. But what you can do is you apply the contrapositive. If the inequality is false, then G is not planar. Okay, this one you can use. Okay. You can use the contrapositive, but you can use the backward. Okay, next one is the homeomorphic graph. Okay, so there's a Kuratowski theorem here. If you find subgraph that is isomorphic, homeomorphic to K5 or K33, then the graph is not tangled. Yeah. Okay, after graph, there's still one more graph thing. So one more graph is the graph coloring, okay? Chromatic color. Okay, to argue, this one is very important, definitely in the exam. So chromatic color here, it is equal to M. Okay, how to prove the chromatic color is equal to M? Okay, so you need to argue why this chromatic color is less than equal to M and greater equal to M. Okay, why is it less than equal to M? Okay, to argue the chromatic color is less than equal to M, you just need to produce one graph coloring with K color, with M, sorry, change to M color. Okay, because chromatic is a least number. Since you can use M color to color the graph, the least number must be less than equal to that number. Make sense? Okay. So how to argue it is greater or equal to M? Usually, okay, usually because it contains a complete graph of Kn. Okay. So for example, inside the triangle, in a triangle, you must use 3 color to color it. At least 3. Okay? Because these 3 are connected, so they have to be different color. And then 4, if K4, you need to have 4 color. That's usually the reason. Usually, okay. There might be other reason, but usually these 3 are the reason. Okay. Not the only reason, but less than equal to M is always this case. Always can be shown by this case. So you can always use this to show that the chromatic color is less than equal to M. Okay. You must use N, be able to use M color to color your ground. So that is less than equal. Okay. Okay, next is trees. Okay, tree. So tree At first, we talk about labeling the vertex. Okay, we give the name, not name. We give some property to the vertex. Talk about ancestor, descendant, parents, children, siblings, internal vertexes, leaves. Okay. Yeah. And then we try to list all the vertex, okay, systematically, which we call the tree traversal on the ordered rooted tree. Okay, so the rooted tree are ordered. The children are ordered from the left to right. So there are four methods here. We have universal address system, pre-order traversal, in-order traversal, and post-order traversal. Right? So it's about whether you visit the root first, or you traverse the leftmost tree and traverse the right tree. Okay, the right. So this part is important. Definitely have one question on this. How to traverse the tree. So make sure you know how to traverse the tree. And then next part is a spanning tree. And spanning tree, there's two types. One is weighted, one is non-weighted. Non-weighted, we have two different algorithm, depth first or breadth first. And weighted one, we also have two primes or cross. I think I don't have question on this, but you just read through for the sake. Then more time on the other part. The last part is the Boolean algebra. Okay. So the Boolean algebra, first we start with the abstract definition of Boolean algebra, and then we talk about Boolean function. So truth table will appear again in this exam, and in the form of Boolean algebra function. This just you learn. Next is to minimize the Boolean function. Okay, minimize the Boolean function we have two ways. One is the K-map, one is the Queen-Minkowski algorithm method. Or I call it the QM algorithm. So the general principle here, they both the same principle. Okay, just different way to present. The general principle here is to find all the prime implicants and then find the least, determine smallest set, smallest set. Okay, I can say this. The smallest set of prime them some and so you can learn KMAT, but you need to definitely know how to. I mean, you can learn QM algorithm, but you definitely need to know how to use KMAT. Yeah, to be in the exam. You need to know how to use KMAT. How to use KMAT method to minimize the. Any question? Anything you want to ask? Anything you want to confirm? Anything you want to confirm? No? The review question is quite useful. You should try and do the review question also. Any question? Okay, if not later after quiz discussion, you can ask again. So maybe one by one, you can come get your quiz and then we will start the discussion at 10. And one by one, you can come and get your quiz.哎，
这种纸袋就是你写的这些东西里面。
没有，我就刚才我有说哪一些重要就要特别多。
就是我的意思就是，
没有，就是这个是那个大纲给你们，知道这样再考虑。
可以跟下次的。
那个指的是，它 definition 是说它是一个 block of one that not contained in a larger block，就是说，就是说，它存在于一个更大的 block 里面。它只要符合这个条件，它就是 prime。
Flux 只能是它一的个数只能是2的倍数。
对，
就是说对于这个图来说是，哪一个？跟这个图就是这样，这样是一个 block。
对，
然后这样和这样
也是一个 block。对
，3个 block，这就是最好的结果。
这个就是所有的 prime integer。
就是也是 list
在这个情况下它是 list。这个情况就不是 list 了。list 是这两个。
就是第二这两个嘛。
对。
这个 essential 是
essential 是指它是一个最大的 block that cover 那个 one 在它的 map 里面。你看 ，OK，
最大的 block。
对，它是最大的 block that cover 那个 one 在 K map 里面。比如说这个，你看它这两个 e 啊，它这个 e 被这个 block cover， 但是这个 e 没有被其他的 block cover， 所以它是最大的 block that cover 一个 e 在那个 K map。可以理解。
就是它跟 prime
有什么区别？是不是？你看、这个中间这个就不是 essential
这个东西
因为它的 e 有被其他的 block cover。你看它是，所以 essential 是说它是一个 largest block one that cover one in the。就是它有一个 e 不是被其他的 block。
它这个 e 不是被这个 block，
但是它存在一个 e 不被其他的。OK。所以 essential。
问一下，basic number，不明白为什么会有2个？
你要证明一个数等于，你要证明一个数是2嘛，然后就证明它是小于等于2和大于等于2，这样它一定是等于2。
因为我在考试。对啊，但是我这个不知道怎样去 explain， 像老师刚才有讲。
对。
那老师，我可以解释一下怎样 explain 这个东西？为什么一个 e 是一个 e？
所以你现在知道为什么需要这两句了？知道为什么要这两句？这两句来证明。
我只知道其中一个因为那个什么 theorem。
没有，你知道为什么需要这两个来证明？
我知道。
OK， 你看 OK 好。 然后你知道为什么小于等于 m 是因为这个原因，因为这个数字的意思是说最少的 number 拿来排那个 graph 嘛，对不对？但是你已经用 m 个颜色来踩这个 graph 了，这样最少的那个数字是不是小于等于用的？
这个等于 m，为什么要比它小呢？
没有，你要证明这个，你要证明这个，你要证明这个，你还不知道，你要证明这个，你还不知道，你要证明。
老师，我问一下，两会是吧？
啊，对，对，
老师，然后
啊，
我还是不明白，
你不明白说？
就是如果我用 triangle，我知道有3个颜色，然后我都知道我的 m 是3呀嘛。
没有，现在就是说你不知道，你要证明它是3，
啊，我要证明，
对，你要证明它是3，
然后我这样证明，
你要证明，你要修这2个，你才可以证明它是3。
是2个，
所以你要说为什么它小于等于3，因为你可以用3个颜色去踩它。第二个，为什么它一定要大于等于3，是因为它有至少3个 vertex 被连在一起，对吧？你看啊，这3个 vertex 啊，互相都有联系啊，就是意思说，你用了一个颜色在这里，
用比它小，
啊
比它大，
啊，
这个我懂了，然后这个小过等于，
小过等于是因为这是最小的数字 ，OK， 这个本身是有意思的，对吗？
romantic，
啊 ，chromatic
等于
的数，对，所以它是对，所以你已经用了一个，已经用了
这样的话 m
啊，
是
我不知道，可能它是，可能它不是，但是那个 list 一定是小于等于这个，可以明白吗？因为比如说班上最矮的是150 cm，OK，这样你100，所以怎么讲呢？你再给我想一下啊，比如说班上最矮的，是不是小于等于我任意抽一个班上的人的高度呢？是不是？对哦，跟这个一样哦，我随便踩3个数出来，这样这个数肯定是大于等于那个最小的数，
所以 m 是m
一个 cover，
然后多少颜色？
m 是随机选的，
M 是随机，没有随机我就
我们把
踩是吧？
把里面的人
这个分区域的，
它的 probability 就算是那个最矮的，
对，probability 是那个最小的，
那 m 就是随机选的每个人。
随机选的，但是你随机的会随机，可以随机，
我们他们肯定可以用多少颜色？来平板这个5个零点，
可以随机，OK 啊，OK 啊
我找一下啊，
，OK，
那是把区域零点，
哎
这是那个小就把人叫感冒了就
，OK，没事，OK，对，好，再见，加油。可是这个要还我
就是红光盘，
啊，
我
你拍一下还给
还是问你
我，拍一下还给我。
那个群是我那个，我那个群我的国家
老师还
不是说
所以它就是一个点，所以你已经放好点了。
来，也
这个点是你这个结论就代表一个可以将这个你就给他读这个图比较分两个这个
OK，好再见，加油。 啊？
你刚刚说只要不是我们那个 paging code，
没有。
我听到我没听清楚你说那个 paging code 是说什么
没有那个题，
啊？那你说
就是没有相关的题目。
哦，没有相关 paging code
啊，哦，
是
哎，
可以问每个
啊，
有多少题这样子？
忘了 relation 有2题。哦，你说总共有7题这样？
总共只有7题，10道题
啊，7题。
，7道题。
Yeah
就是
啊，其他的应该是一题，估计
每个单元一题。
差不多吧，我忘了。哎，伟纯呢？哦，在厕所啊。Hello, testing. Okay. Let's try. Okay. How's the quiz question? Source. Okay. Yeah. Similarly, two announcement is divisibility always on Z plus. No matter what I wrote, if I wrote Z is a typo, you just regard the Z as Z plus. Okay, Z plus. And then Euler path again. When you draw the path, right? Some of you just draw arrow on the graph. So you see, if you draw arrow on the graph, if I walk from here to here, so I have to go here or I have to go here. So there's an ambiguity here. Okay. So unless you draw something like this, non-stop path, and or you just label by vertex also can. Yeah. But don't just draw arrow on the graph. I don't know how to go where to start also. Okay. Draw non-stop path or give the vertex also can. Okay. This question I forget to put one hint. Actually, I should put prime factorization theorem here. Okay. If you put into prime factorization theorem, and then you just need to prime factorize them, it's easy to see. And we will see in a moment. So task 1.1, why the divisibility of Z plus is antisymmetric? So for every element Z plus, if A divide B and B divide A, then A equals B. Okay. I just asked you to explain, no need to prove. Maybe this proof is only part. 1.2 is draw the Hassel diagram. Okay. So if you split the number into primes, then you will make sense of this Hassel diagram here. Okay. So what I do is just product of power of 2 and 3. Okay. So 8 is just divisible by 2. 27 is just divisible by 3. And then 12 and 18 are mix of 2 and 3. And then 216 is actually the LCM of the second level. And 2 to the power 3 and 3 to the power 3 are combined them. LCM. Yeah. So if you see it in this way, you will build the Hassel diagram faster. And then next, determine whether it's totally ordered set or not. Again, some of you, I think quite good, you remember that totally ordered set is a chain, but this one is not a chain. Okay. So what does it mean by a chain? You can compare every pair of, if you found 2 elements that's not comparable, then it is not a totally ordered set. 1.5, I think quite a lot of you get it. Upper bound of 2, 3. Okay, very good. Some of you get it. And where's the minimum maximum number. I miss it. Okay, so there's 1.3 here, right? I missed this question. 1.3. Oh, I wrote it inside here. Okay, so 1.3, right? Now you just say 6 is the maximum element, and then there's a greatest element. I give you mark in the quiz, but make sure in the exam you write 216 is also a greatest element. I think this is how it is asked in the textbook, but textbook also gives 216 as the answer. So you also need to tell me which one is the greatest element. By telling me which one is the greatest element, you also answer. Okay. So in exam, you need to tell me what's the greatest element. Okay. Any questions for this? Surprisingly, you guys did better in graph. They only few get 9 or 10 in this section. Get 10, and then Hongling, go Hongling. Li Qihui, who is Li Qihui? Is Li Qihui here? Oh, Li Qihui. Okay. Qihui got 9. Xie Jingxi. Xie Jingxi. Jingxi. Oh. And then we turn. Ming Hao, Ming Hao here. Ming Hao not here. Chan Ming Hao. Yeah, that's all. 9, 10. Okay. Oh, did I forget one question? Oh, determine whether the process is lattice or not. No, because 2, 3 has no lower circle bound. For this kind of question, right? For this kind of lattice question, the lattice definition is every pair have a lowest and top and the least, right? So do you really want to check all of them, all the pairs? This one take a lot of time. So usually when we set the question we set the question to be short, okay, not buying time, okay. So either you can quickly find the pair, or you can quickly deduce that every pair you have the greatest or lowest. So you no need to go and check one by one. Okay. So one way is to really set you think that it's norm and then find one. The other way is it is really obvious. Okay. If something is not obvious, then you should go the other way. Okay. It's not trying to buy your time, so there's some quick. Okay. Okay, next part is we got the Hassel diagram as a graph. Okay, so you turn the Hassel diagram into a graph. So you don't care about the vertex anymore, the labeling of the vertex. So is the graph bipartite? Okay. If it can be colored by 2 colors, it is bipartite. Okay. So some of you draw the bipartition is also okay, also work. Okay. 2.2, determine whether it has an Euler circuit or Euler path. Okay, so you need to answer both part here, because you can see there's a 4 mark here. So Euler circuit, 2 marks, yes or no, and then reason. Euler path, yes or no, reason, 2 marks. Okay, so you can construct the path to prove me there's a Euler path or Euler circuit. And then what you do is you also, like what we said just now, you count the degree of the vertex. Okay. If not all vertex have even degree, then there's no Euler path. Euler circuit. If there's a Euler circuit, there are exactly 2 vertex with the odd degree. Yeah. Yeah. And then you draw the path. Okay. So you can draw like me. So you start it, and then you put an arrow. So I know where to start, and then I will start walking again. Yeah. Yeah. So you need to put the arrow where to start, and then make sure you have a non-stop path here. And so that I can trace the path. And then 2.3, determine whether it's planar or not. Okay. I think most of you get trapped in this question here. So you think that there's a K5 hiding inside. Actually, this question is how I started to design this quiz. So I want to start with either a non-planar or planar graph. And I make it into a Hassel diagram. So at first I also thought that this is non-planar. But I keep trying and then I see that it is actually planar. Exactly because I cannot find K5 inside. Yeah. So why is it non-planar? You can take the point of 18 or 12, that label 18 and 12, and then take it up. Okay. You can take this vertex up, and then you can construct the non-planar graph like this. Yeah. So you can take the vertex up. So you draw an isomorphic graph that has no edge crossing. Draw an isomorphic graph that has no edge crossing. So some of you also straight away see there's an edge crossing. Oh, it's not planar. Yeah. Yeah. You need to try if you can draw isomorphic graph such that it is not edge crossing. Okay. And some of you also go and compute the E2V minus 4 and then say that it's planar because it satisfies the inequality. Okay. So that corollary is not going backward, or only going forward. Okay. Only when it violates the inequality, then it is not planar. Okay, that one is true. The other way is not true. Next, 2.4. What is the chromatic number of the graph GP? Okay, so this one actually is almost 3 marks, because if you get 2.1, you can color with 2. Then this one is already 2, the chromatic color number. Okay. One reason you can give is it is bipartite. So every bipartite graph has chromatic number 2. Okay. You don't need to show less than equal to 2 or greater equal to 2. Because in class we already said that bipartite graph always have chromatic number 2. Okay. Since it is bipartite, the chromatic number 2. You don't need to show less than equal to 2 or greater. Okay, 2.5 bonus question. Can you draw a graph that is not isomorphic but homeomorphic to the graph? Okay. So you cannot use the same graph anymore. You cannot keep the number of degree of the number of vertex. Okay. And but homeomorphic, you cannot simply add edges. Okay. So what you can do is you just add vertex to the edge. Elementary subdivision. Yeah. Subdivide the edge. Yeah. So you can put a lot of new dot along the edge. Then you will get the answer. It's not isomorphic because the degree, the number of vertex is different. There's no bijection between the number of vertex. Okay. But it is homeomorphic because they can be obtained from the elementary subdivision. Okay. And then the last part is Euler characteristic. Okay, this one is not in the book, in the textbook. This one only in the lecture. So if you know if you listen what I'm talking about, then the Euler characteristic is 2, which is the 2 in the Euler formula. R equals to E minus V plus 2. 2 is that is the thing that we call the Euler characteristic. I think quite a lot of you, not a lot, a few of you got full bonus mark. Yeah. Jing Xin got both full marks. Su Yang also get 9 in the graph. Vivian also get 10 on the graph part. Christianity also get 9. Daniel. Po Jiachun is here. Jiachun here. Oh, okay, yeah, got 9. Yap Queen got 10. Hey, is she okay now? Is she okay now? She okay. Yeah, she got 10 in the second part. Tell her. Apparently last week, her friend asked her whether question 1 is lattice or not. And then after she said yes, and then she fainted. Hopefully she's okay now, huh? Yeah. Any question? Any question? I think I will post up the quiz solution afterward for you all to revise. Anything more you want to go through? The review question, have you tried? Okay, go through the review question. There's some really similar question in the review question with the exam question. The review question, some of them are really similar in the exam. 哇，他改6个，对，
就是16，
更做不出来。对啊，你不能重复。太应该也也是你的6次方法，
对呀，
有点10的，没有固定的一个。哇，结果你是让你，然后6个问题。
一个一个啊，7、6、
啊，
这个时程表没有
93。
可以。
没有换工，你那个
没有强迫。
156吧，到那个东西。
首先改正。
刚刚这个是
那个是也不敢听啊。
还得马上我发现这做。对吧？讲这一块， 可以看，那他
对啊，
也不是他厕所。潜水，当兵法的地方，有点险。
哎，不会，不会，我做好。
不是我那错了，把这个
对，我以为你聊的是这样的，下班你这样出来一个这样子出来一个，你要干啥呀？
没有让
没有干嘛？我以为你是，
哎，这样下一次我应该要这样涂。下一次没有下一次，我有开始没有下一次，那我就这样涂。涂中涂，对吧？还是直接
家女儿，哇，厉害！
这都请你来出哦。
我觉得
哎，他很傻啊，讲 There's no way to do these things. There are not enough item. Not enough item. Not enough item. 不能 not enough item. 没有就 not enough item 吧，他乱了。
这个又是什么鬼？
没有那个可能另外一个算法。
啊，它题目有4个。
Yeah. Not enough item.
来个 choose from 6，然后
不够。
not allow，不可以 order 也诶
嗯，
order 跟 repetition 老师他那 pattern 是什么鬼啊
哪个 order 只是说
？order 是它有 P 没有 P，
有分，就是这6个东西是有差别的。
order and repetition 这是一个意思。
两个意思。repetition 是说你可以重复它，还是不可以重复。比如说这个就是说，
就讲 P
啊
rep 就是那个多少 P 多少的话是
order 就是说，比如说12跟21是不一样的
所以这个是
啊。
P，就很像
P
我如果讲
P 对 P 对，这行。
然后 repetition 是 C，
没有 repetition 是它可以重复，可以有1这个东西，也可以有22这个东西。因为你 P 的话不可能
就是12跟21这个是2个东西。
不是
就我可以重复。
啊，你可以重复写的。对 P 的话不能重复嘛，P 只有6个东西在那里。
那有类似这样的概念啊，就如果我讲，我是 order 的话，这样我6:10这样子啊。
喂，不能6:10，还不能。
10P6了，10个里面选6个，
也不是这一题哦。
这个是上一题啦，就
对啊，上一题。
如果是我讲它是 order，然后这个是 no repetition，
对啊，就是 no。
然后有 repetition 的话，就是讲它如果我要选6个，这个有10个 choice，10个 choice 就变成是10的60吧。
可以啊。
然后如果是讲 order and have repetition， 诶，哦，这两个是相违背的，这是 order and repetition。order and repetition。order 就是1、2跟2、1是一样的东西啊，就变成 C 啊，就现 C 啊。哦，就 unorder and repetition 就是多少 C 这样子。诶，老师用 unorder 的话是讲 express 啊。order and repetition 它里面那个 express 是这样。unorder 然后可以 repetition 对。你应该是要把那个 permutation 那个给除掉诶。
嗯，
对的，就是比如说这样。就这样算。他应该是讲一个表达的本等，好像我是 order 我懂它是 P 啊，unorder 我懂它是 C，然后 repetition 的话就是这种，但是 unorder 没有 repetition 它是一个 pattern，这个我就不太懂这个。either C either P，然后这个情况是有 repetition，but repetition 但是 unordered 就总的什么 expression。怎样？你要 unorder，然后你又可以算那个 repetition 的东西，对不对？这是我选的。这点我选10C6，假设我十个选6个，然后unorder 选的话，应该讲我10C6，然后乘得68。然后我想一下这个题目，item that unordered，懂了，我很晕这种东西。要想一下，我想一下。可以想一下，如果这差别的个题目，我的 repetition 也是很 low，我的 unorder，它答案是这个，我在想一下怎么点。这是这样分，就是 unorder and repetition。那第一的他们这个上题没有 E，还没有 E 的题，E 没有 E 的答案在这个。没有学过，你也还是可以直接涂一个。我是懂，我比较晕这种那个什么的了，要搞清楚。E 的第一是5005，这样叠吧，他没有教两项，是应该是一样的。好，可以啊，可以啊，可以。If not any more question, you can pass me back the quiz and then good luck in your exam. I know. Happy New Year. 这个几次算1分吧？解释，因为它有4分嘛。
本来想要，本来我想要给1分给，你 part 没有画出来。
画没有画对啊，我画可能没画错。
OK，拜拜。
没有画对啊，这样。因为我的画是要全部跑，但是我来不及写。
608。OK，怎样啊？
真的啊，我那又可以重。
OK，
告诉外面签到，
要不要签到？
这后面有传到那边去。
还是你去厕所？
住院也是还没签到。的，来合作。
哎，你们没有 presentation？你也有，每个人几点？
哦，4点开始。所以有一些人没签到的。
就3、